This is lesson 2.1, integers and rational numbers. The first thing you need to know in this chapter is that there are all different types of numbers, and you have to understand the difference between these types of numbers. The first are whole numbers. Whole numbers are positive and whole. That means there are no fractions or decimals involved. For example, 1, 2, 3, 4. 0 is also considered a whole number. There are also integers. Integers are positive and negative, but are whole numbers. So integers could be -3, -2, -1, 0, 1, 2, 3, and so on. It continues forever. Rational numbers can be put in a fractional form where a and b are integers and b does not equal 0. So for example, a rational number could be -1/2 or 3/4. Rational numbers are real. Real is just a bigger category. All numbers that a value can be assigned to are considered real numbers. So for example, infinity is not a real number because we can't set a number to represent that symbol. We will work with whole numbers, integers, and rational numbers in algebra. We do, and real numbers, we certainly do not work with numbers that are not real. If you take a look at this diagram, you can see whole numbers in the middle. That's the smallest group. Whole numbers are also integers, but integers include negative numbers. And then we have rational numbers that includes all integers and whole numbers. But rational numbers can be fractions, remember, positive and negative fractions. And then real numbers encompass all of these things, so it is the biggest group of numbers. And real numbers include everything except numbers that cannot have a value set to them. After reading this section, you should be able to graph numbers on a number line. I would hope that you could do that already. So I'll give you values, and you actually have to place them on a number line like this, -2, -1, 0, 1, and 2, to see where the negative numbers fall and the positive numbers fall. Just to rehash the basics, positive numbers are always to the right of 0 on a number line, and negative numbers are always to the left. The negativity increases as you move to the left, so the numbers are going to get larger in size or distance from 0, right? But smaller in real. Do you understand that? For example, if I go far to the left on the number line and I put a -3 there, -3 is further from 0 than -2 and -1, but it's a smaller number than -2 and -1, right? There's less there. You should be able to put numbers in order from lowest to highest. So if I give you negative, positive numbers, you should be able to put those in order. And you should also be able to identify the type of number that something is. So take a look at these in the example. I gave you 4 numbers, 5.6, -2 2/3, and -24. So look at them and think about it for a second. You can pause this if you need to, and decide what type of numbers they are. Are they whole? Are they integers? Are they rational numbers? Well, the first one, 5, it's a whole number and it's positive. That means it is a whole number, and it's also an integer. Is it rational? Yes, it is, because rational numbers include all whole numbers and integers. So 5 is all 3 of those things: whole, integer, and rational. If you look at 0.6, however, 0.6 is not a whole number. It's just a part of a number. We know that integers have to be whole numbers. They can be positive or negative. That is not a whole number, so it's not an integer, but it is indeed a rational number, because remember, rational numbers are in the form of a divided by b, where b is not equal to 0. What about -2 and 2/3? -2 and 2/3 is not a whole number. It has a fractional part to it. It's also not an integer because integers are whole but can be positive or negative. But it is indeed a rational number. Negative 24. Negative 24 is not a whole number because whole numbers have to be positive. I know that might be a little bit confusing because you see no fractional part to that, so you think it's whole, but it's not because it's negative. It is, however, an integer because integers can be positive or negative, and it's also rational because rational numbers can be placed on a number line. Okay? That's why infinity doesn't work because we can't put infinity on a number line. We're going to take a look at opposites and absolute values. For opposites, you have to change the sign. So if the number is positive, the opposite would be negative. And if the number begins negative, then the opposite would be positive. Okay, so take a look at these four examples. We're going to find the opposite of the following. We have negative 1/2, 3/4, 82, and x. Since negative 1/2 is negative, then the opposite of negative 1/2 would be positive 1/2. Since 3/4 is positive, then the opposite of 3/4 would be negative 3/4. In the same way, 82 is positive, so the opposite of 82 is negative 82. Now, what usually trips people up is variables. Variables work exactly the same way as numbers. So the opposite of x would be negative x. Right? You have to understand that, negative x. I'll write that on here. You can read this as negative x or the opposite of x. I usually read it as the opposite of x, and I'll tell you why. Because sometimes the number that represents x is negative. Think about that for a second. What if x is negative 3? Then the opposite of x is actually positive 3. So calling it negative x isn't exactly correct. You may want to watch how you think about these kind of things because we're going to be working with a lot of numbers, both positive and negative, and a lot of variables, and it's going to get very confusing. Start to think of that negative sign as the opposite of sign. And I know it seems silly with numbers, but it won't seem silly when we work all the time with variables.